side camera. Where did you go? There we go. All right. Welcome back, everybody, to another live stream repair. Oh, let's get our microphone up here. And a little extra lighting. There we go. All right, so we've just got this one HomePod in from Myron. They dropped it off locally, and we're gonna get it fixed up here today. It's got the classic common no power issue that these first gens love to experience, where the Schottky barrier diode on the amplifier board inside loves to spontaneously fail and take the whole pod down with it. This is what appears to be just a bad batch of these diodes floating around out there, because we continue to only see diodes with certain date codes failing, and plenty of examples with diodes much older and newer that continue to work just fine. So let's plug this thing into some power and check our symptoms, see what we've got going on here. Apologies for the grumpy kid in the background there. Nothing you can really do about it, yeah? So, we've got a known good power cable here connected to our kilowatt meter. That'll tell us how much power this is drawing, and it'll give us an idea of, like, if it's a blown fuse, we wouldn't see any power draw. If we've got the shorted diode that we normally see, we'll most likely get around 3 to 7 watts of power draw. And if it's a lesser common short on the logic board, which we do see on occasion, it's probably going to be around 1 or 2 watts of power draw. Of course, you've got other failures like random shorts on the power supply, but we've really only seen maybe 3 or 4 of those out of the near 1,000 that we've had come in and out here. So anyways, let's plug this in, see what we're dealing with. Alright, no signs of life, and yet we are pulling 4 watts of power there. So like I said, this does appear to be another one of those dead diodes on the amplifier. But let's take it apart and find out. I'm gonna clean the bottom of this really quick first, because it's pretty gross. Where did this come from, too? Oh, wow. Oh boy. Okay. We're gonna need to find another lazy Susan for us to do our repairs, because that ain't gonna work. So anyways, we're gonna start with our iFixit Jimmy tool, wedge that level and parallel with our plastic top here underneath, and then we're gonna work our way around a few times actually, cut through that adhesive. We're not trying to pry this up at all. That's how you scratch and crack it. We're just cutting through that adhesive until it pops off all on its own. Be patient with it. I know it looks like I'm just ripping and dipping through this thing, but you do as many of these things as I have, and I would be surprised if you're not going this fast by now. Not without some damage to your hand in the process, I'll tell you that. We're going to work on those T6 screws to get the display out now. And then back with our jimmy tool, we're going to pry that display up. And then actually wedge our plastic tool underneath that and use this for the actual prying here around the frame. So that way our plastic tool is not going to scratch up our PCB here, whereas our metal tool can very easily damage this and scratch it. And yes, that will definitely cause problems if you scratch deep enough or the wrong place. So only use the metal tool to give yourself a gap. Don't go all the way around and scratch the crap out of your display there. Back to our T6, we've got a few screws here. George, welcome. All right. We're going to drip some alcohol in there so that when we go to pry this basket up in the next few steps, it'll be a lot easier. Here we go. Hey Cameron, welcome to the stream. Let's get our ribbon cable. Let's get you guys up close too, so you can see what I'm doing. We're gonna pull this ribbon cable down and away from its adhesive. And then we're gonna carefully scrape away what's connecting the rest of it there, so that way, again, when we go to pry this basket up, we don't rip this ribbon cable in the process of herky-jerky whippersnapping the basket off 10 feet away. And then this is still, stuck to it, so that's not a good time. And I don't have tons of these cables sitting around left, so be careful around these. Or you might end up finding yourself buying another HomePod for parts just to get another one of these cables. Anyways, back with our T6 again, we're going to get these screws for the basket out so that we can pry it out. I was taking one apart for myself earlier this morning. It was like 3 in the morning, something awful like that. And I didn't feel like using the alcohol before prying this up, so I didn't. And boy, was that a rude reminder of how rough this used to be without before that kind fellow dropped in our chat a few I think it's almost been a month or so ago now, and suggested the alcohol trick around here before prying this up, and boy does that make it easy. Okay, how does our woofer look? It all checks out. Looks good, no damage or any signs of abnormal wear on the subwoofer. And of course it certainly smells great. So let's get this layer out. This is what's, this part here is what actually seals the subwoofer and the bottom half of the HomePod together. You could have the subwoofer in here and not have this on, and everything would still be perfectly, entirely sealed. No glue at all. And even then, this glue wouldn't even act as a half-decent failover seal if this one, in this layer here, this rubber grommet around the edge, if this were to fail, this glue isn't going to help at all. I'm telling you that because the inconsistency of the application of the glue, like see here, there isn't even any glue over here that would stop any air from going through if this gasket were to fail. So I just don't see why, if they put it in there for acoustic or secondary or failover reasons, they didn't do a good enough job for it to matter. So that's why you don't see us gluing these things back together. It does not seem necessary. And yes, a good point to make is, well, they wouldn't do it for no reason. I may not know the exact reason. I can speculate. I think maybe they just wanted to glue everything together to make it, honestly, maybe just make it harder for people to get into them. Because you look at the second gen HomePod has zero glue anywhere. It's all gaskets and grommets. Maybe they did, like, honestly put the glue in there thinking that it was going to be functional. But if there was any functional reason for them to have put that glue in there, they didn't do a good enough job, because it's just so inconsistent between each HomePod. And then you've got some of these that we take apart where literally half the ring doesn't have any glue at all. It's just completely naked. Alright, I'm liking the mat so far. There's been generally enough space for me to lay everything out here without really worrying about clobbering anything. I guess it'd be nice if I had a place to put this subwoofer, but we've kind of taken that space up with our test one here. Whatever. We've got our amplifier out. So we're going to get up close and take a look at our Schottky diode here. That's this guy with the date code of 1746K on it. And if it's not 1746K, it's 1748K that we continue to see failing here on the channel, with no exceptions to that after still the hundreds and hundreds of that we've seen. So, before we jump the gun here, we're going to grab our multimeter and just really quickly confirm If this beeps at us, then our diode is indeed dead. And sure enough, that's a dead diode. So it's getting the deed done. And here we go. Let's see how this mat handles the heat, because with my Weller, my old red Weller mat, I'm not sure how much I really liked that. Aesthetically, and the actual layout of it, 10 out of 10, I loved it. I loved the slots on the left, or on the right-hand side for my screws. But it just did not handle heat nearly as well as I expected. And to be fair, yeah, see, this one's starting to do it too. No mat's going to be able to tolerate you sitting there with a heat gun at 500 degrees Celsius for more than a minute or so. But ideally, you have a board preheater, and you preheat your board before you do this. That way, when you do go to pull your parts off, nothing is going through nearly as much intense and sustained heat. That's like the 10 out of 10 top professional way to do it right there. If you're looking to do it better than anybody else, that's how you do it. You preheat the board, and then you jump in with your heat gun. And it's like 15-30 seconds out with the old and with the new, you're done. Puts less stress on everything overall. But a decent board heater is going to cost you a little bit, as is every decent tool in any seemingly any trade at this point. But so far, I mean, my red mat would bubble up and discolor really quickly, even after the first few repairs. This one, it raised a little bit, but it's doing pretty good. It's doing better than the Weller. I can't even find my red Weller anymore on Amazon. The original listing that I bought it from is down, and Weller has a few for sale, but none of them are the exact same layout. And I was very, very, very attached to that layout. Kind of sad to see it go. But it was its time. If you've watched any of our recent live stream repairs, you'll see anytime we get up close how beat up that thing is. It was time. But see, now with our board already warm, we're only here for 15 to 30 seconds and we're done. Got a little goober in there. A stray ball. Alright. So we're gonna wave this cool really quick. Hey Martin, welcome to the stream. It is it's handling it really well. Like, yeah, I can touch that with my bare hand now, and it's very hot, but it's not too hot for me to touch. And it definitely feels like a higher quality than the old Weller here. And here's a size comparison. But what I'll always miss is this part right here. because it was really nice to be able to put each individual screw for the top half in here, and then just dump all of the amp screws in here, and them all just basically fall into their little squares. But here we don't have any of that, so it'll take a little getting used to. But like I said, I cannot find that exact same layout anywhere anymore. So I'm guessing maybe that was like a counterfeit, and I just got really lucky, but I still ended up paying as much for that as I did for this. Okay, so let's drop our amp back in. Pop a few screws. Oh yeah, I was talking to somebody a little bit more about one of their repairs after we had done it recently. And I'd pointed out that, and they didn't notice this, but I don't think most people noticed this. Your screws for the amplifier have a little washer on them. And they're not just flat normal washers. They've got a wave on them. They've got a bit of like a, there's a specific term for this, and I'm totally losing it, but the idea is it gives it pressure points, places for the screw to bite down on. And then when you tighten it, when you torque it down, it will resist loosening itself from the vibrations of you bumping the beads. That's also why you sometimes see the scores on the amp here, the circular scores around the screw holes here on the amp board. That's from our washers getting a good bite. Lock down that amp, that ribbon cable into the amp. We'll grab a power supply. Make sure that's firmly plugged in to the amp, and then we'll connect its cable for the AC. We're going to bring it over here, plug in our subwoofer on the bench here, which, where's my multimeter? Where are you at? Did my driver reset itself again? Nope, it's still the original driver. Windows has not destroyed it yet. We'll set our serial port to COM6, I believe it was. And then, there we go. Alright, so like I was trying to say, we've got a subwoofer here on our bench, which has an extended connection into our amplifier here, and it's also got the same leads connected to it going to our multimeter on the screen here at the bottom right. And so that'll give us an idea, not of course if this thing powers on or not, but if it's got good bass, because we're going to test it with a factory reset logic board here. And if the amp has any DC offset, or in other words, DC voltage being put out of the amp and going into the speaker there, which is not good. DC voltage destroys speakers and amplifiers, especially the parts that aren't expecting to see that DC voltage. An amplifier's job is to amplify anything it's given, be it AC, which is what an audio signal, analog audio signal normally is, or the DC voltage that you may end up seeing when your filters go bad. That's those ceramic capacitors that naturally decay over time and lose their effectiveness at filtering this DC voltage, and in some cases end up doing the opposite effect, making it worse. So let's see if this power's on, see if it's got good sound, and what its DC offset is. And there we go. We've got power. So as for DC offset here, the amp is built to tolerate up to around 200 millivolts at the output, which we actually say more than 50 millivolts and we replace our filters. We don't wait till it's around 200 millivolts. We say anything more than 50 millivolts can cause damage. And then once you get like more than 2 to 3 volts DC, that's when you get like death farts. But ours here is looking really fresh with only 4 millivolts, so that is excellent, and it's holding relatively steady. It's not growing rapidly towards and past 50 millivolts. So this looks ready to finish putting back together. Let's tighten up our power supply. And then we'll get our amp screwed down. Oh, how's my voice? Is it too loud? Is it too quiet? Is there room to turn the gain up a little bit? For you guys, I turned off the case fans on my desktop, so only the radiator fans for the CPU and the GPU fans are going on it now. And I hope that makes it a little quieter, and maybe we've got room for some more gain. I also moved the microphone. It's now hanging up over here, and it'll probably move again, but it's now like right next to my face and equal distance from what we're working on here. So let me know how it sounds. I do have, it's like 75 degrees in here, even though it's only like 70 degrees outside. Probably like closer to 78 in here now. So I've got a couple of fans going on throughout the house. But let me go close my bedroom, or let me go close my door here really quick and we'll see how that really sounds. Okay, so the door's closed. On an ideal day, this will be the quietest the background noise will be. Yes, of course, I would have the toughest one for last. The one between these two caps right here. You can't fit the screwdriver straight down in it or you'll bend these apart. No good. Don't do this. All right, is it sealed? Yes, it is. All right, we stick that ribbon cable back up underneath our basket and then plug our logic board back in, set that down, get our frame in place, and then we'll fill our screw holes back up. There we go. I'll pop a few screws in there real loose so that we don't want to tighten this down yet. We just want it to hold in place until we can pull the drawstrings tight and feed the lip of our mesh into the lip of the mid-frame here. Not under it, not over it, into it. Just going to squeeze that together as we pull the strings up like that. And then we can switch between doing that and pulling these apart crisscross to tighten that up. Push this down with 2 fingers and we'll keep it down as we tighten it up. Once we got 2 of them in, we can let go. Make sure that power connector there is nice and settled into place again. It'll click into place if it's been misaligned. And we're going to wrap it up. You don't really need to do this perfectly. It doesn't have any function. Once you screw this drawstring down, it doesn't really matter how you wrap it. Just make sure you don't have any slack flopping around to allow for any strange noises. Let's plug that display back in, lock it down, line it up. Ouch, that was my elbow. Snap, crackle, pop, my body. That's what my friend would say. Dude pops like a bowl of Rice Krispies every time he like bends his knees. I'm starting to now too, though. But that's okay, because we have arrived at the end. Let's stick our top down. We can wiggle it a little bit until we find where it likes to settle the most. And then we'll press that down before it cools off too much, make it stick down nice and well. And then if we're looking for any extra depth or flushness here, we can always pull and squeeze this up a little bit and try to stuff it in there a little more. And there we go. Of course, like all things Apple, and especially these HomePods, you may not getting looking perfect, but these things didn't even look perfect from the factory, outside or in. But let's see if we got it working again. There we go. That's actually all that we've got to fix here today, so I'll go ahead and give the spiel now. If you're looking for more info on doing your own HomePod repairs, like the common issues and how to fix them, what parts and tools you need, or my contact info so you can ask a question that's not answered on the website, or reach out to me for getting your HomePod fixed here on the channel, check all that out on my website up there, nixfix.com. And let's see if this works.
I'm having trouble connecting to the internet. For more
There we go. What about the volume buttons? They both light up nice and evenly. So, that's it. Folks, I hope you enjoyed this live stream repair, and I'm going to give the new Gamers Nexus Flux soldering repair mat let's say a good 9 out of 10. I would like to have seen maybe more screw size specific spots, so that way I can either dump a handful of screws and just kind of wiggle them around and they'll all fall into individualized compartments. Aside from that, relative to my old red Weller mat here, which I would give rather probably a 6 or a 7, even though I like the layout more, it was smaller, just as expensive, and did not hold up nearly as well. So, hope you all enjoyed this stream, and I'll catch you in the next one.